Okay, so welcome back to our chapter review for our Chapter 3 test. Okay, this is video 2 for that review. Hopefully that last proof didn't make you want to turn it off. Hopefully you're ready for another proof because that's what's coming first. Okay? Okay, so again, hopefully you take a minute to write this down, pause the video, and we'll begin the proof. Alright, so statements and our reasons. Okay, and hopefully I don't have to scroll down too much. Okay, I will scroll down just to get as much as I can on there. Good, okay. So first thing is always the given, right? So we always start with the given. Line L is parallel to M. Angle 1 is congruent to angle 3. Alright, and we will use that information because it's given to us. So let's mark that on the picture. So L is parallel to M. So here's L being parallel to M, and angle 1 is congruent to angle 3. Okay. Now, what does this mean to us? That's the question. I use a different color. Okay, so what can we say from these lines being parallel? That's the question. Well, if we look, L and M are here. Here is our transversals. A is a transversal, and B is a transversal for L and M. So on B, there's only one angle, so let's not worry about B. Let's look at A. Angle 1 and angle 2. Look at what kind of angles they are. Angle 1 and angle 2 are alternate exterior angles. And if we know lines are parallel, we know that alternate exterior angles are congruent. That's exactly what we can say. Angle 1 is congruent to angle 2 because they are alternate exterior angles. We used the fact that lines are parallel, so it's just the alternate exterior angles theorem, which gives you parallel lines. So that means that since 1 has one congruent marking, 2 gets one congruent marking as well. So now look at all three of your angles. Congruent, congruent, congruent. They're all congruent to each other. If angle 1 is congruent to angle 3 and angle 1 is congruent to angle 2, we can use the transitive property. Right? Angle 3 is congruent to angle 1, angle 1 is congruent to angle 2, angle 3 is congruent to angle 2. We can say that angle 2 is congruent to angle 3 by the transitive property. Okay? But now, let's look at angle 2 and angle 3. For lines A and B, and this time transversal M, 3 and 2 are alternate interior angles. And if we can show that alternate interior angles are congruent, then we can say that the lines A and B are parallel. Well, look what we did. Angle 2 and 3 are congruent. The angles are congruent. The alternate interior angles are congruent. Therefore, the lines are parallel. Step 4. A is parallel to B. Because we had alternate interior angles congruent, we're proving lines parallel, converse to the alternate interior angles theorem. There's the proof. Very easy, or easier, I won't say very easy, easier if there's no supplementary ideas. Okay? Alright, so there's the second proof. Okay, so here's the next picture. So again, it's very complicated. So before you draw it, let me describe. T is going down through, this is line T. You have line A and B right here, 39 degrees, 101 degrees. You have line C and D down here, 42 degrees, 98 degrees. Okay, so again, pause it, write it down, and then come back to me. So the question is, what lines are parallel? That's the question. Now, if I look at this picture, what are the two possibilities? Well, I think that A and D could be parallel. And I think that C and B might be parallel. Right? Just by the way they look. So those are the two lines, the two sets of lines I'm focusing on. So let's see what we need to do. All right? in this picture, okay, and I'll try to use pink. Let's focus on A and D first. Here's A, and here's D. Okay. Here's your transversal T. Okay. This angle right here and that angle right there, they are going to be alternate interior angles. Here's your transversal. Here's a line. Here's a line. They are in between the two lines on opposite sides of the transversal. They're alternate interior angles. So what is the measure of that angle total? This is the question. Well, this angle right here, if we go 42 plus 98, we get 140 degrees. Same thing here. Add them together. Okay, 101 and 39, 140 degrees. They're the same. These alternate interior angles. So let's put alternate interior angles. They're the same, meaning that they are congruent. So in this picture, if the alternate interior angles are congruent, then your lines A and D are parallel. A parallel to D. So we know that. So there's one. Okay. Now I'm going to switch to orange. Let's see how this goes. So now let's focus on C and B and transversal T. Okay, so sorry for the mess. Let me make that a little bit bigger. There we go. Right. So again, if you can't copy this down, it's okay. Paying attention is good enough. So we need to now look at, again, alternate interior angles. Look, here's my two lines. Here's my two lines. There's my transversal. This angle right here, just this small one right there, and this angle right here, they are alternate interior angles. So again, we're looking at alternate interior angles. We have the angles already there. 98 degrees and 101 degrees. They are not equal. Therefore, alternate interior angles will not be congruent. And if alternate interior angles are not congruent, then your lines cannot be parallel. B is not parallel to C. So that was a little bit easier because there was no addition to do. All right. So there's that problem number 7. Those are kind of tricky. You really got to think about them. You got to think about them. Okay. All right, moving on to the next. Okay, so here's our next problem. Here's our picture. We have two lines J and K, and we have line T going through. The question is, how do you show they're parallel? How to show J is parallel to K? That's the question. How do we show that? Using the information up here. Well, if you look at this 140 degrees, that's degrees, 140 degrees and 40 degrees, there is no relationship. They're not one of the 4 relationships, okay? But they give us angle 1 for a reason. Let's find the measure of angle 1. Angle 1 is a linear pair with the 40-degree angle. Linear pair. That means they are supplementary. So the measure of angle 1 plus 40 degrees should equal 180. Subtract 40 from both sides. That means the measure of angle 1 is 140 degrees. This angle right here is 140 degrees. So what does that mean now? Look at angle 1 and the 140 degree angle. These two angles are corresponding. Angle 1 is corresponding with the 140 degree angle. And we know that the measure of angle 1 is 140 degrees. They're congruent. Corresponding angles congruent. If corresponding angles are congruent, then you know your lines are parallel. So what does this mean? This means J is parallel to K. That's how you'd show that those lines are parallel. Okay, the last two examples I have are algebraic examples of finding parallel and perpendicular lines. So we want to find in number 9 a line parallel to y equals 2/3 x minus 2 that passes through the point -1, 2. Okay, this is what we want to do. All right. So take the line and identify the slope. This is slope-intercept form, right? Y equals mx plus b. Your slope is m, so m is 2/3. M is 2/3. Okay? Since your lines are going to be parallel, this is the slope we use. M is 2/3. Now the point they give you, -1, 2. We are going to use point-slope form. This is your x1 and your y1 in point-slope form. If you remember point-slope form, y minus y1 equals m times x minus x1. This is point-slope form. We are going to eventually get it to look like slope-intercept form, but it's going to take a little bit of work. Okay, so the first thing we do is we plug in our 3 numbers. Y minus 2 equals 2/3 x minus, and x1 is a -1. Okay. How do we solve this? Well, first thing is change the double signs. Minus minus is plus. And now we distribute the 2/3. Y minus 2 equals 2/3 times x. And 2/3 times 1 is just 2/3. And then we need to add 2. Uh-oh. We get y over here. We get 2/3 x right there. But then what the heck do we do with this? Well, let's bring it to the side. It's positive 2/3 plus 2. Put the 2 over 1. And now, let's get a common denominator. The common denominator is 3. Make that a 3 by multiplying. And if I do it to the bottom, I have to do it to the top. So we get 2/3 plus 6/3. And that's just 8/3. Positive 8/3. And there's the line parallel to this line through -1, 2. Okay? All right, now let's do a perpendicular example, and I think you'll be ready for your test on Friday. I hope you feel this helps. I think it does. So now we need to find the line perpendicular to 4x plus 7y equals 13, passing through the point -2, 6. Okay. So again, first step, take that line for x plus 7y equals 13. Take that line. We need to put it in slope-intercept form. We need to make it look like y equals mx plus b. Subtract the 4x on both sides. Cancels. 7y equals, put the x term first, -4x plus 13. We want it to look like mx plus b. Still got to get the y by itself. Divide by 7 over here. When you divide by 7, y equals, you divide both by 7. Both. So it's 2 divisions. -4 divided by 7 is just -4/7 x. Positive 13 divided by 7 is just positive 13/7. They don't simplify. So this is all just so we can identify the slope of this line. The slope of this line is -4/7. Our lines are perpendicular. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocals. Both opposite reciprocal slopes. Opposite reciprocal slopes. So the slope we're going to use is the opposite of this, which is positive, and the reciprocal. Sorry about that. Which is 7/4. There's the slope we're going to use. 7/4. The point, -2, 6, is our x1, y1. So now we use point slope form. Okay? y minus y1 equals m times x minus x1. Y minus y1 is 6 equals m 7/4 x minus a negative 2. And now we simplify. Let's change the minus minus to a plus plus and distribute the 7/4. Y minus 6 equals 7/4 times x. And now 7/4 times 2, this is actually going to simplify to positive 7/2. This 2 and that 4 will cancel. You can take the 2 out of the 2 and leave you with 1. Take the 2 out of the 4 and leave you with a 2. It's division, common factor. Okay, so the 2 becomes a 1, the 4 becomes a 2. It's 7/2 times 1, which is 7/2. Okay, fractions. Then we add 6 to both sides. Y equals 7/4 x. And now how the heck do I do that? Well, come over here. It's positive 7/2 plus 6. Put the 6 over a 1, and you know you got to multiply by, not 3, not the last problem. You got to multiply by 2 to make the denominators the same. 7/2 plus 12/2. Add the tops, 19/2. Positive 19/2. So there you go. Oh. Positive 19/2. And there's your line perpendicular to the line given through the point. So you can hopefully feel prepared for your test on Friday. Okay, good luck in studying. We'll see you then.